You're welcome to today's class. Today we are still looking at storage classes, but today we are going to look at static storage classes. So we are looking at static storage class. So this is what we are going to look at today. The last class we did automatic storage class. Today we are looking at static storage class. So I'm still going to use um, the same thing. I'm going to have location. So where will it be stored? Um, the lifetime or span, and then default value or scope. We'll look at the scope, and then we'll look at the default value. Right? So we are going to look at these four things using these storage classes. So let's write a program to demonstrate this. And then, so the first thing I'll do is include stdio.h. So I told you these static storage classes are like the historian of the community, right? They keep memory. So we are looking at family, we are looking at the culture, we are looking at the tradition. That basically are the people you classify under what? The storage class. So include stdio.h, then I will say void, and then I will say static example is a function. Then inside this function, I am going to declare a variable static int count. Let's call it count. And then I will assign 0 to it. Then I will say count plus plus. Then I'll say printf, and I'll say count equals %d/n. Then I will look at count. Okay, so I will close my function. Then I will create my main function, which is the entry point of the program, int main. Then inside this main, I'll call my static. So static example. Then I will call it again, static example. And then I will say return 0. So I will close this. All right, so this is my program. Now, looking at this program, I brought in my preprocessor directive, including a library, standard input output library, because of this printf. Then, so this printf definition is inside this standard input output library. Then I'm creating a function. It's not going to return anything. It's just going to perform a task. So inside this function, I create a variable. I call it count. But this variable is what? Static variable from the integer realm. So I'm assigning 0 to it. Then I'm going to increase this variable by doing what? Count plus plus. Then I'll print out the value of this variable on the screen. Then inside my main, I'm calling this function, which is the static example, the first time. So what will happen? Now, this is my memory layout, right? So I have this, I have this, I have this, I have this. So I'm just going to leave this place as what? The command line argument, command line arc, and what? And the environmental variable. So this place is what? Stack. This is what? Heap. Right? This is what? Data segment. So data segment. And then this is what? My code /text segment. So this data segment is what? Initialized and uninitialized data segment. So this is my memory layout. Okay. Now this is what happened. So listen very well. This is the catch. Even before main is before we enter this main function for the program to start, the first thing the compiler will do is the compiler will look at this entire source code. The compiler will see this static. So the way the compiler is going to interpret this place is that go to the data segment of the memory, right? And create a variable called count and assign 0 to it once. That is even before the program will start, before the main function will be called. The compiler will have gone to the memory, the data segment of the memory, and created this variable count and assigned a value to it as what? 0, meaning initialize it. So this data segment is divided into two parts, uninitialized and the initialized. So because it's initialized to 0, so it will go to that segment and create count and initialize it once. Right? So this is like the soul realm, meaning whatever we do in life echoes in eternity. You remember that line? So meaning the soul realm saves that memory. So it has done that. Then it will call main. That is, main will be loaded. So our starting point of the program, it will start. So the moment you, inside this main, you call this static example, which is this function, control will come here. Now, when it enters, it is loading this static example in the stack, not in the data segment. Now, inside this stack, it is not going to create this again because this is no longer going to be there. As at the time you call this, the first, what this did at the initial point of running this program was to go to data segment and create this count and assign 0 to it. So calling it now is just going to access this count and the value inside it will be what? 0. So count plus plus will increase the value to what? 1. So this is the memory. So count is created and value is assigned to it. When you call it now, it will not see this part again. It's just going to, with this static, access the memory, which is what? Within the scope of this static example. And it will increase what? Count plus plus. It will change it to what? 1. Then it will come to this printf and it will print out count equals to what? 1. Then it will encounter this exit curly bracket and it will return back to this main. Now, when it returns to this main, this variable count is not destroyed because it is what is in the data segment. It is not destroyed. But what this static is simply telling you that the only way you can access this memory is through this function called static example. So it means the scope of, so location is what? Data segment, right? The lifetime is throughout the program. So throughout the life of the program. So it's not true, it's not only limited to the life of this function, this static function. No, it is going to exist throughout the entire program. Until the process stops, this static will exist. So the lifetime is throughout the program. Then the scope is local to this what? To this function, right? Now, if it is outside, it will be global. So the static storage class can be both local or global. So in the case of this function now, it is local to the function, meaning you cannot access it, even though it's existing, but you cannot access it unless you enter into this function, right? Then the default value is what? 0. So even if I don't assign anything to it, that is, I do this, the default value will still be what? 0. So, but I'm assigning a value to it, right? So then I call this function, it print out count what? Count 1. Then it returns back to this main and it will call it again. Calling it again now, it's still going to access, it will go to the data segment and access this place. The value 1 is still existing. So count plus plus will change it to what? To 2. So it's to print out count 1, then it will go again count equals to what? 2. So count equals to 1, count equals to 2. That is what this will print out. If you call it again, it will print out count equals to 3. If you call it again, it will print out count equals to 4, because it will be incrementing what is existing inside it. So when you exit this function, this variable is not destroyed. So when Paul said, every sin a man commits is outside the body, but the sin of immorality is against the body, what he was saying is that a memory location is created in you that only you can access. But through that sin, whoever it is can access that variable. So if you have something very crucial in that variable, somebody external can access it through this sin. So meaning I can create a pointer inside this function and access that pointer from outside to access this memory location. That is the trick that you can play with it. So meaning even if this function disappears, I can use a pointer to access this memory. So when Daniel accessed the spirit realm, the temple, the main address of the temple, through a pointer, even though the physical temple was destroyed, that was the concept he was using. So this is what you call what? Static. That is the beauty of what? Static storage class. It allows us to save the variable in the data segment, and then giving us access to that data segment, to that variable within the scope of that function. So even when that function is destroyed, it still retains the memory. So these are the historians. Somebody in the company who understands the entire history of that company. So even when staff comes and go, new staff will come, he will still be able to tell you the history of the company and carry everybody along. Right? So it is very crucial. So that is what I want to show you with this concept. So let's go to code block and let me demonstrate this for you to see. Don't forget to give me a thumbs up. And if you have not subscribed, please click on the subscribe button. Also help to share this video and tell me what you feel about the class. So let's go to code block. Okay, so this is our code block, and this is the static example program. So like I showed you, static example, then inside this function, I am creating a variable called count, and it's static. So the compiler is going to create this in the data segment, and then when I call the static example inside the main function, it's simply just going to increment it and then print out the value. And then when I call it again, it will increment it again and print out the value. So let's run this script for you to see what the output will be. So as you can see, the first one, it printed out count equals to 1. And then the second one, it printed out count equals to 2. So I have explained why it is like that on the board. So till we see in the next class. Bye-bye.